The first thing that we need to know is the physical state of each compound. To know the physical state, I totally recommend to use the table of solubilities that I gave you. Okay? So I want to know what is the physical state of this compound. I want to know the physical state for this other compound and also for this one. Okay? Those are unknown. I want to know the physical state because that will define if I need to do dissociation or not. Okay? So to know that, all I need to do is using the table of solubilities. Okay. How well do you see this table? Is this okay? Do you see everything? Bueno. Okay. Okay. So, first of all, I need to read in this table something about acids, okay? Because the first compound here is an acid. How do I know it's an acid? Because it begins with hydrogen. This tells me that this is an acid. The second compound, it has hydroxide ion. When you have a hydroxide ion, it's known as a base compound. So, by knowing that you have acid and base, we're gonna look for in it, okay? We're gonna look for in the table of solubilities, what does it say about acids and bases? The first rule doesn't help us because it talks about just sodium, potassium, and ammonium, and any of those are part of this formula. The second compound is hydroxide, okay, and it's not part of this rule neither. It says nitrates, acetates, and chlorate. None of them participate here. It says most chlorides are soluble. No, we don't have chloride. We have something about the sulfates, okay? We have something about the sulfates, but remember, we're looking for acids. Here is carbonate, and here is sulfides, which isn't neither, okay? So, in the table of solubilities, you cannot define whether they are solid, liquid, gas, or aqueous solution. So, for you to know, maybe I want to write this too. Acids and bases are AQ, always. Acids and bases both are prepared with water, which means that the physical state will always be aqueous solution. And remember the rule, if it's aqueous, means that you can do dissociation. So, I will be doing dissociation for the acid, for the base, but I still don't know about this compound right there. Barium sulfate. Okay? So we look for the table again, and we look for the rule about the sulfates, which is right there. It says, most sulfates are soluble. So we're talking about that sulfates, most of them are soluble. But let's continue reading about the exceptions. Except those of barium, strontium, lead, calcium, and mercury. If you've noticed, barium is part of the exceptions, which means that in the end, barium sulfate is going to be insoluble. Now, keep this in mind. Those that are soluble are going to be in aqueous solution, and those that are insoluble are going to be known as the solids, or what we also known as the precipitate. So far, we have already discovered that barium sulfate is going to be the precipitate of the reaction. Now we need to write the physical state of each. We said that this one is insoluble, so it's going to be solid. We said that acids and bases both are in aqueous solutions, so you write the physical state over there. And now your equation is ready to dissociate. Now I'm going to move this away because I need to work in the physical space I have. Okay. Now, remember, those that are aqueous are gonna be you're gonna be doing the dissociation equation. So, dissociation equation for the acid, for the base, but not for the precipitate and not for the water. Okay? So only those that are aqueous are the ones that you will dissociate. So I'm gonna be using colors for this. I'm gonna be using red for my acid, and I'm gonna be using blue for my base. Okay? So I'm going to write the dissociations of each. Remember to write the coefficient of each ion. Okay? So, sulfuric acid is an acid that is made of two hydrogen ions and invisible one sulfate ions. Okay? Remember that 2 is coming from here. This 2 tells me the amount of hydrogens. The invisible one is coming from here. You see that there is nothing, means that you just have one sulfate in it. If you had two sulfates, you will have parentheses and a 2 outside, for example. But because you don't have it, it's going to be just invisible one, the invisible one that is included here. Now, the second compound, which is the base, is going to be dissociated as invisible one barium ion. Barium is a metal which has a charge of 2 positive according to the periodic table. Now, the other ion is hydroxide, and as you can see, we have 2 outside, which means that in the end, we have 2 hydroxide ions. Hydroxide has a charge of -1. Now we continue. And remember to write the physical state of each. So you have AQ for hydrogen, AQ for sulfate, AQ for barium, and also AQ for hydroxide. Now we have the rest of the equation, that is the products part. In the products, I have my precipitate, which cannot be dissociated. So I'm just going to write it. BaSO4. I indicate that it's a solid. And then my water. Water is liquid, which means I won't do the dissociation of it. Okay? So I'm just going to write it down exactly in the same way it was. H2O, and the physical state that is liquid. Now, the second step for net ionic equation is to eliminate the ions that are in both parts of the equation. How many ions do we have in this equation that we can eliminate? Can I eliminate hydrogen? Can I eliminate hydrogen? Okay, repeat that. Can we eliminate hydrogen? Remember that to recognize the ions, you must check the charge. Okay? So you have charge here, there, here, there, but you don't have any charge here and no charge over there. So this means that here I have ions, but in my products I don't have ions. So what to do when this occurs? What can we do when this occurs? The rule says that you are going to eliminate the ions that are in both sides. Because you don't have ions in the right side means that you are not going to eliminate anything. Okay? So because you don't have ions in the product that can be eliminated with the ions in the reactant, you're going to say ions cannot be eliminated. The reason is there are no ions in the product. So what to do when this occurs? Because if in a quiz I give you an equation like this, what are you going to do? You're not going to say, no, miss, this exercise cannot be done. No, it's not like that. So what to do when this occurs? Well, when this occurs, the only thing that you have to do is leave the equation just the way you left it, like I do here, okay? Just write the equation again with its ions. You can get rid of the parentheses if you want, and voila, that's it. You need nothing more than that. You can also get rid of the invisible ones to actually make them invisible, and that will be it. This will be the net ionic equation for this exercise. From the procedure that I did, From the procedure that I did, do you have any doubt? That's it. That's the net ionic equation. You don't need to do anything else. This will be enough. Do you have a doubt in the procedure? Bueno. Let's try with one more example, but this one you will do it alone, okay? I'm gonna give you, I'm gonna give you 5 minutes for you to work with the first part of this exercise. Gonna copy and paste. Okay. It says, write the net ionic equation for 3 um, 3 moles of hydrosulfuric acid plus 2 moles of bismuth 3 nitrate produce bismuth 3 sulfide solid and 6 moles of nitric acid. So I'm asking you to write the net ionic equation. The first part we're gonna do it together, okay? You're gonna tell me if we are going to dissociate each compound. So I'm gonna call them by their name. This is going to be my compound A, B, C, and D. Let's analyze. The first compound, are we going to do dissociation for it or not? Can dissociation be done in the first compound? Look at the physical state. The physical state aqueous means that you can do dissociation, yes or no? Thank you, Nicole, for participating. Aqueous means dissociation. So you're going to be doing dissociation for A, dissociation for B, and dissociation for D. The only one who won't require dissociation will be the solid, the compound C. So from now, I'm going to give you 5 minutes to complete the dissociation of the compounds A, B, and D.